In this lesson, I'm going to walk you through the process of using Git for branching and merging. First question you might want to ask is, why would you want to branch and merge? Git is one of the few version control systems that really doesn't have a lot of overhead around branching and merging, so it's really something that you, when you start using Git proficiently, will start doing quite often. What does it allow you to do is to isolate experiments, isolate work units, parallelize. It'll support long-running topics, and you can even do hotfixes. So here's a simple flow of I've got one commit. Now I'm going forward, use these kind of shorthands and only show the commits. I'm not going to show the actual tree of blobs and trees that it points to, just to kind of economize on the space. But just understand that this commit represents the tree and subtrees and blobs within that commit. Notice also that when you make a Git commit, you will always want to put a message, which you can do with a -m, and then just a short string of characters that describes what you changed, what bug you fixed, what issue maybe it's tied to, and so forth. This has become very handy when you need to start troubleshooting, or if you get a bug that breaks a build or something. Now, here's how you can basically create a branch. In this example, I just said get branch feature, and that creates a branch. Now remember that branch is just a reference to that commit. It didn't really create any other collection of files. You just basically created a reference that points to that commit. Now if I do get checkout feature, that's going to take the head reference and now point to the feature branch. It's not going to change my working directory because at this point, both master and feature are both pointing to the same commit, therefore have the same state of the working directory. But let's say, working on feature, I add a file called feat.c, and then I commit it, of course, with a message, in this case, added feat.c. That's just going to create another commit. It's going to move the feature reference to that new commit and the head with feature. Now, if I make another change to a file and then add it and commit it, which I can do in this case with git commit -a-m, and then a commit message. The -a is just basically saying that if it's already tracked, go ahead and commit whatever's changed that's being tracked. So it's a little bit of a shorthand. It's not the most precise way of working, but in context, it's okay, I guess. But again, it's just going to create a new commit, and it's going to move the feature and head to point at that new commit. Now, let's say I want to go back and do some work on a new branch. I can do in a single git command, git checkout -b issue master. Now, what that breaks down to is a git checkout on master, and then git branch issue, which is going to create a branch called issue, and it's going to check out that issue branch. So at this point, I'm going to be working on the issue branch. So I'm going to add a file called issue.c. When I commit it, notice that it moves the issue and head to point at the new commit. Now let's say I want to do some more work on issues, so I'll go ahead and make some changes and then commit them. In this case, using the -a-m flags and a new message for that commit. And you'll see that it just moves again the issue and the head reference to the new commit. Now, at any point I can do a git log --stat, which is going to give me kind of a perspective or insight into what's changed. I'm depicting that in this case just with some transparency to what files are in each of those commits and what the hash is. Again, these are very, very shorthand hashes, but they at least give indication to what's changed. So let's take a look at this and try to figure out what's going on. Now, notice that in this first example, the original file F13, that's the hash for a file named main.c, in the first commit is the same. However, in the second commit, it's changed to 27b. That's a new hash. That means that file has changed. Now, in this case, F13 on a different branch, this is again the issue branch, has the same hash from the commit that master is still pointing to. F13 is the same, and the new commit, nothing changed as well, so it's basically the same file. Here's a slightly different one though, because the original commit didn't have feat.c, so it looks like I've added a file. 45e is the hash, and even from that commit to the next commit, that same file, feat.c, has a new hash, therefore it must have changed. Now let's look at this last file. Again, this issue.c on the issue branch didn't exist in the commit that master is still pointing to. but from the first commit to the second, it went from D4A, which again, that's the hash, to E59. Therefore, it must have changed. So in the first commit, that file was added. In the second commit, it was actually modified. And that concludes our lesson on Git branching.